following are 5 manufacturing tools, principles, and concepts that I believe are very useful to know about in design and manufacturing in the modern age. First on our list is Design for Manufacture and Assembly, or DFMA. When designing a new product, it is vital to design with the manufacturing process in mind. Without a viable manufacturing process, the product will never exist at all. This is what makes DFMA so important, as it ensures that the product is designed with ease of manufacturing and assembly in mind. For example, let's look at this Lego set from my personal collection. All pieces in this set were designed with the specific context of Lego's injection molding process in mind. This ensures consistency within the pieces and also a smooth manufacturing process. The set was then designed for ease of assembly, with each piece being placed in a sequential order in the building steps to ensure that the user has a smooth building process. Outside of Lego sets, DFMA is vital for any manufactured product to make sure that the product is designed efficiently and with the user's assembly capabilities in mind. The only limitation in this process is the understanding of the manufacturer. They must know their own capabilities as a manufacturer to a T, design well within their own skill sets. They must also have an in-depth understanding of the user's capabilities to design well with them in mind. After all, if the consumer is not satisfied in the assembly process, then the product is a failure. Next up, we have agile manufacturing, which is more of a conceptual process that a manufacturer can strive for. The purpose of agile manufacturing is to ensure an adaptive and responsive manufacturing process. This way, companies can respond quickly to changes in consumer needs. There are 4 key principles that agile manufacturing employs to meet this goal. First is iteration, or the continuous improvement of design ideas. By allowing for iteration, designs can improve and grow over time. Next is bottom-up planning, which is the business understanding the details of their engineering process and then forming a general goal around that. This allows for a wider spread of ideas and a faster response time for implementing said ideas. Third is flexibility, which ensures that unexpected changes can be accommodated fast and efficiently. Finally, there is augmentation, meaning that a manufacturer can modify and rearrange their process in an efficient and reliable way. As you can tell, agile manufacturing is a very beneficial practice for businesses to stay on top of changes in the marketplace, but requires a manufacturer to understand not only the consumers they produce for, but also their own skills. They also must utilize versatile manufacturing processes that can be applied to different contexts. If a manufacturer can't change what they do on the fly, then agile manufacturing would be a lot more challenging to apply to their business. With that being said, this process can be applied to any manufacturing principle or any manufactured good, as it is looking at their process and seeing how you can make it more agile and efficient for changes. One interesting and more modern process in design and manufacturing is computer integrated manufacturing, or CIM. CIM is the extremely broad application of computer technology to manufacturing processes. Some goals of CIM are to optimize manufacturing operations, to automate a variety of steps in manufacturing, from material allocation to inspections, and even general management of the manufacturing process. There are 4 major capabilities of CIM, which is why manufacturers are so interested in this integration. First is improved responsiveness, therefore improving their agile manufacturing skills. Second is efficient use of materials and labor. Third is better control of production and management throughout the process of manufacturing a product. And finally, there is decreasing the cost of production while still ensuring the quality of a new product. My personal favorite subgroup of CIM are industrial robots, which are able to replace humans in dangerous or difficult manufacturing responsibilities, leading to a more efficient and reliable process. The issue of these impressive robots, and honestly a lot of CIM applications, however, is that they require time, expertise, and a lot of money. CIM requires extremely skilled experts to help set up and ensure the correct application, because if CIM is applied in the wrong way, it is a huge waste of money. And that setup requires time and a major investment that many manufacturers struggle with. If a manufacturer understands their needs, has enough capital to employ the correct experts, and is willing to spend time setting up the ideal system, then CIM can benefit their company in ensuring quality products are manufactured quickly, safely, and reliably. An important task that must occur throughout the design and manufacturing of a product is quality assurance. Quality assurance extends beyond simply inspecting units of the product after manufacturing, as any errors would be pretty costly to fix at that point. Instead, manufacturers employ total quality management, which is the goal of preventing defects instead of fixing them down the line. This concept can be applied to any device in development, which is why it is so important in manufacturing. By ensuring that a product is designed with quality assurance in mind, the manufacturer is able to reliably produce a high-quality product. This means that less time and less capital is wasted on fixing past production errors. Of course, there can still be individual errors or instances that are not accounted for through this process, but it makes sure that any systematic errors are not an issue throughout the manufacturing process of a product. Finally, another important process in design and manufacturing is process validation. This is an offshoot of quality assurance, in which a manufacturer routinely analyzes the results of their own manufacturing to verify 3 goals. 1. That quality is designed into the product. 2. That the manufacturing process was designed to meet desired quality levels. And 3. That the design process is reliably meeting said levels. These goals are investigated in 3 stages. First is process design, which is validating the design of a product so that the manufacturing process selected meets quality requirements. Next is process qualification, which is when the manufacturing process selected previously is investigated at the moment. Then finally, there is continued process verification, which is repeating the above stages to ensure ongoing quality. This method is very important to the design of a product because it keeps quality at the forefront of the design and manufacturing process. As stated when discussing quality assurance, maintaining quality in production is not simply looking for errors in finished units. It is instead a long process that very thoroughly investigates for any issues that could occur. That is why process validation is so important, and it can be applied to any manufactured product. While it is true that this can be very time-consuming, especially if the process for a product is very thorough and strenuous, the sacrifice of time is worth it in the long run to ensure that a product is designed and built well. It also allows the manufacturer to learn more about their own processes, giving them the opportunity to apply the lessons learned from process validation to a variety of other manufactured products.